Exercise 7.10 question 5 integration 0 to pi by 2 sin x dx upon 1 plus cos square x, right? So here we'll assume cos x as t, right? So this will be minus sin x dx will be dt. So I can write this as sin x dx as minus dt. Also, if I keep the value of x as 0, I will get the value of t as 1. Whereas if I keep the value of x as pi by 2, I will get the value of t as 0. So this time it will be from 1 to 0 minus dt upon 1 plus t square. We'll take this minus outside and this will be dt by 1 plus t square, right? So this is, you know that 1 upon x square plus a square is 1 by a tan inverse x by a, 1 to 0. So we'll keep it t as 0 first and then 1. So tan 0 0, this is pi by 4. So the value is pi by 4, right? Sixth question, integration 0 to 2 dx upon x plus 4 minus x square. So you can see that my first term is negative. I don't want that, so we'll take minus common outside and we'll write it as uh, square minus x. So if I find the last term using formula middle term square upon 4 into first term, so x square upon 4 into x square, I will have my last term as 1 by 4. Actually I am taking minus 1 by 4. I am balancing the equation by taking plus 1 by 4 and this plus 4 as it is. So finally I will get dx upon 16 plus 1 17, which can be written as root 17 by 2 whole square minus x minus 1 by 2 whole square, right? So this is of the form 1 upon a square minus x square. Is answer is 1 by 2 a log mod x plus a upon x minus a, and the limit will be from 0 to 2. So here 2 will get cancelled out and I will have 1 upon root 17 here, and after taking LCM we'll keep the value. So it will be 2x minus 1 plus root 17 upon 2x minus 1 minus root 17, 0 to 2. Now see, I can keep the value of x as first 2 and then 0. So keeping the value of x as 2, I will get 2 2s are 4 minus 1 3 plus root 17 upon 2 2s are 4 minus 1, that is 3 minus root 17 minus log mod. If I keep the value of x as 0, I will get root 17 minus 1 upon here. If I keep the value of x as 0, then 2 zeros are 0. I will get minus 1 minus root 17. I will take that minus common, and as it is mod, I can write this as root 17 plus 1. Now applying the properties of log, you know that if the two logs are in subtraction, I can take common log and will take the division. Dividing means multiplying it with its reciprocal. So what I will do is I will take the reciprocal of this and will multiply. Right. So I will get a 3 root 17 plus 3 plus 17 plus root 17. Binomial to binomial multiplication. 3 root 17 minus 3 minus 17 plus root 17. So here I will get 20 plus 4 root 17 upon minus 20 plus 4 root 17. Right, I can take 4 common outside to get 5 plus root 17 upon uh, will again take minus common outside from this and will write 5 minus root 17. I can write that. As it is mod, I can do that. Now still what I will do is I will take the third conjugate of this, that is multiplying numerator and denominator with 5 plus root 17. So I will have 5 plus root 17 whole square, and here a square minus b square. What I did is I multiplied the numerator and denominator with 5 plus root 17, which is the third conjugate of that. So I will get a square plus 2ab plus b square, whereas here it will be 25 minus 17. This will be 42 plus 10 root 17 upon 8. I can take 2 common outside from numerator and denominator. So 21 plus 5 root 17 upon 4 is my final answer. Question 7. Integration minus 1 to 1 dx upon x square plus 2x plus 5. Right. So if I find the last term using middle term square upon 4 into first term, my middle term is 2x. So 2x whole square will give me 4x square upon 4x square. I will get last term as 1. So I will split this 5 as 1 plus 4. I can write this as x plus 1 whole square plus 2 whole square. This is of the form 1 upon x square plus a square, whose answer is 1 by a. tan inverse x by a, and we'll keep the limit minus 1 to 1. So keeping the value of x as 1, I will get here 1, and keeping the value of x as minus 1, I will get 0. So this is 5 by 4 and tan 0 is 0. So my final answer is pi by 8. Right. Question 8. Integration plus 1 to 2. 1 by x minus 1 by 2x square e raised to 2x dx. So here I will assume 2x as t, 2 into dx by dx1, dx will be dt, and dx will be dt by 2. Also, if I keep the value of x as 1, I will get a value of t as 2. Whereas if my value of x is 2, I will get a value of t as 4. So this will be integration 2 to 4. And this will be 2 by t, as x will be t by 2, and this will be t by 2 whole square, that is t square by 4. This will be 4 upon 2 t square e raised to t dt, and this will be dt by 2, not just dt, it will be dt by 2. So I can take this 2 common outside, and this also 2 from the numerator. So I am left with e raised to t bracket 1 by t minus 2 by 2t square dt. I can cancel this 2 to this 2 also. So I am left with e raised to t 1 by t minus 1 by t square dt. So if I assume f of t as 1 by t, my f dash of t will be minus 1 by t square. So this integration is of the form e raised to t f of t plus f dash of t dt, whose answer is e raised to t f of t 2 to 4. Keeping the value of f of t as 1 by t 2 to 4. Keeping the value of t as 4, I will get e raised to 4 by 4 minus e raised to 2 by 2. Finally, I can write this as taking e raised to 4 common and taking LCM of 4, I will get e raised to 2 minus 2 upon 4. If you want some more elaboration, then I can write this as 2e square by 4. Now you can see that I can take e square common outside. I will have e square minus 2 upon LCM is 4. So this is my final answer. Question 9. Here it is given integration 1 by 3 to 1 x minus x cube whole raised to 1 by 3 upon x raised to 4 dx. So what I will do is I will take x cube common outside. From this I will get 1 by x square minus 1, right, whole raised to 1 by 3 x raised to 4 dx. Now we'll give individual powers. I will write this as x cube raised to 1 by 3 and 1 by x square minus 1 raised to 1 by 3. So if you are not getting, then you just multiply this x cube inside this, you will get back the same term, that is x minus x cube. Now this 3 will get cancelled out and I will have x raised to 1. This x and this one of that x will get cancelled out and I will have dx upon x cube. Here I will assume 1 by x square minus 1 as t. Minus 2 upon x cube dx will be dt. And if I keep the value of x as 1 by 3, I will get the value of t 1 by 3, that is 1 by 9. 9 will go up. 9 minus 1, I will get the value of t as 8. And if I keep the value of x as 1, I will get the value of t as 0. Right. Again, how to simplify this? I want just dx upon x cube. So I can write this as minus dt upon 2. So just replacing the values, I will have 820. This will be t raised to 1 by 3 and this will be minus dt by 2. So we'll take minus 1 by 2 outside. Integration 820 t raised to 1 by 3 dt. This will be x raised to n plus 1. 1 by 3 plus 1 will give me 4 by 3 upon 4 by 3. Limits 8 to 0. So 3 will go up and this will be 3 by 8. Keeping 0 will give me 0. Keeping 8 will give me 8 raised to 4 by 3. So this will be minus 8 by 3. And I can write this as 2 cube. 3 will get cancelled and I will have 2 raised to 4, which is 16 and minus 16. 2 ones are, sorry, 8 ones are and 8 twos are. So minus minus plus 3 twos are 6. Right. Question 10. Here it is given f of x is integration 0 to x t sine x, t sine t dt. So we'll apply integration by parts. T sine t dt minus derivative of t integration sine t dt whole dt. We'll keep the limits afterwards. Integration of sine is minus cos dt by dt1. This is minus cos dt. So this is minus t cos t. This minus will come outside and integration cos t dt is sine t. Now I will keep the value, that is limits. If I keep the limit as x, I will get x cos x plus sin x. And if I keep 0, then that is 0 multiplied by cos 0 will give me 0 and sin 0 is also 0. So this is my f of x, but they are asking us to find f dash of x. So we'll take derivative minus x. We'll apply product rule. We'll leave minus x. Derivative of cos x is minus sin x, plus we'll leave cos x. Derivative of minus x is minus 1, plus derivative of sin x is cos x. So f dash of x is minus minus plus x sin x minus cos x plus cos x. Minus cos x plus cos x will get cancelled out and I am left with x sin x. This question 9 and question 10, both of them are of multiple choice type, that is MCQs. The option suitable in question 10 is B. X sin x is the option B, whereas here the 6 is A. The correct option is A.